Hello guys, welcome to my channel Medicinal Pharma Education. Hope you are doing well. In the previous video we have discussed lot of things. Let me recall what we have discussed. This is the syllabus. See, we have completed the quantum number, their roles. In the NMR principle you have completed, instrumentation is completed, solvent required in NMR you also completed, relaxation process and the types also we have discussed, NMR signals in various compounds also we have discussed. Now chemical shift and factors affecting chemical shift, we are going to discuss this topic. Okay, let's not waste time. See, okay, chemical shift is defined as the difference between the absorption position of the proton and the absorption position of the proton of a reference compound is known as chemical shift. See, here the chemical shift is defined as the absorption position of proton and absorption position of the proton of a reference compound. The difference between these two protons of the sample and the reference is called chemical shift. Okay. Chemical shift is measured in delta values. The value ranges from 0 to 10 for the most of the compounds. See here they gave the formula delta equals to H reference minus H sample divided by H reference into 10 power 6 parts per million. Okay, I think so you have understood the concept of chemical shift. It is the difference between the absorption position of the proton, okay, and absorption position of the proton of the reference compound. The difference between these two is called chemical shift. The formula you can see. Next, shielding. What is meant by shielding and de-shielding? These two topics are very important and they are very easy. See, when a proton is present inside a magnetic field or closer to an electropositive atom, more applied magnetic field is required to cause excitation. Such protons are called as shielded protons, and this effect is called as shielding effect. See, I will explain in simple terms. If an electropositive atom is present, example Na plus is present near the nucleus, then the external magnet we are using external magnet, this magnet should the strength of these two magnets should be increased to excite this nucleus. Okay, if the chlorine, if sodium is replaced with chlorine, electronegative atom, then less external field is required. That is called shielding and de-shielding. Shielding means it is protecting this, de-shielding means this is not protecting the nucleus. Okay, if here chlorine is not protecting the nucleus, here sodium is protecting the nucleus, that is called shielding and de-shielding. That's the main difference. That's the concept behind the shielding and de-shielding. See, I just read out this line. When a proton is present outside a circulating magnetic field, or when it is attached to an electronegative atom, less applied magnetic field is sufficient for excitation. That's what I explained you. Such protons are called as de-shielding protons. This effect is called de-shielding effect. That's it. If there is an positive, it causes shielding. It like shield, it protects. Okay, de-shielding means it does not protect. Okay, that's what de-shielding and shielding. See, in other terms, we call shielding, we call upward field. Okay, and de-shielding we call downward field. Okay, in other terms, and see, we can see de-shielding has higher values in the chemical shift, and shielding has lower values. That's the main difference. Okay, what's the difference is hydrogen attached to electropositive. We have already seen the definition. Hydrogen atoms are attached to electron positive, like Ci, carbon, Si. Okay, here sp3 hybridization is going on. In this, hydrogen attached to electronegative, so that it is de-shielding. Example, oxygen, nitrogen, sulfur, chlorine, fluorine and bromine. Pi electrons closed or close to the double bond, triple bond. Here pi bond also causes de-shielding, and so the pi bond is present, right? If pi bond is present, If it is double bond, sp2, if it is triple bond, sp hybridization. That's the main concept regarding the shielding and deshielding. Hope you are understanding. Next we will start with the factors affecting the chemical shift. This question is very important. Almost every question paper they are asking either the chemical shift or the factors affecting. Okay, and so that you just concentrate on these 8 types. Okay, first, electronegativity, inductive effect, isotropic, hybridization, solvent effect, hydrogen bonding, complexation, and van der Waal deshielding effect. These are 8 types, and we will go through one by one very easily, and hope you are understanding. If you are not understanding, just please tell me so that I can improve my videos. Okay. Electronegativity. Electronegative atoms present in the molecule tend to draw the electron density towards themselves and deshielding of nucleus. See, already we discussed it right in the previous point. What electronegative atom, it draws the electrons to themselves and it causes deshielding. Okay, we have discussed in the definition itself in the deshielding. See, electronegative atom present in molecule tends to draw the electron density towards themselves and deshielding of the nucleus occurs. This is what occurring. Okay. Next, an increase in the electronegativity of the surrounding groups will result in decrease in the electron density and lead to increase in the chemical shift value due to the shielding of the value. See here, we have already discussed if electronegative atom is present, then automatically deshielding it causes, and where deshielding it causes, it goes to the higher value. See here, we have, see here, in deshielding the range is higher. That's what we electronegativity is about. See, that's why an increase in the chemical shift value due to shielding of the nucleus. Example, if you take methyl CH3COH, okay, if C or H is attached, then it is called shielding, and these atoms are attached, then it is called as deshielding. Okay, that's the effect of electronegative atoms. Next, inductive effect. See, in inductive effect, the presence of electronegative atom or group in a molecule makes the proton deshielding. We have discussed. Okay, here higher the electronegativity, greater will be the deshielding, and thus the chemical shift value will also be more. And they are giving the x values, how it is increasing: fluorine, chlorine, bromine, iodine. See, which has the more the electronegative atom, the more the chemical shift value. See, fluorine is most electronegative atom in the periodic table, so it has the most chemical shift compared to iodine. And here you see these all atoms causes shielding, and this causes deshielding. Okay, for example, you can write. Then isotropic. We have discussed in the difference between, if pi bond is present, what it causes: deshielding. Due to the presence of the pi bond, the presence of a nearly pi bond greatly affects the chemical shift. As we already discussed, if the pi bond is present, it causes deshielding. If you are not understanding, first understand the deshielding and shielding. It's very important, and every difference is based upon the shielding and deshielding. So if you are not understand, just go back and see it. Next, hybridization. How it affects the chemical shift. As the s character of the carbon atom increases, the electron cloud is held more closer to the carbon and providing less electron density of shielding of protons, and thus the chemical shift increases. See here what it is telling: if the pi bond, if the s character is decreasing, if s character is increasing, okay, f character is okay. Here the s character is like 25%, here 25% s characteristic, here 33%, and here 50%. 50%. See, as the s character is increasing, then the what it is causing, it is increasing the chemical shift value, and see, as the chemical shift value is increasing, the S value also increases, S character also increases. Here S percentage 25%, okay, and here 33.33%, and here 50%. As the percentage increases, the chemical shift value also increases. This is the effect of the hybridization. I hope you are understanding. I hope you have understood. Next, solvents. The solvent used in NMR spectroscopy should be chemically inert, uh, mag, magnetically isotropic, and should dissolve the solvent to a reasonable extent. See, based upon the solvent itself, the NMR spectroscopy is like most of it is dependent. See, free from isotropic effect. If an isotropic solvent is present, it also affects the result, and the chemical shift also occurs. If an electronegative atom is present, what it causes deshielding. If an electropositive atom is present, then shielding occurs. So solvent selection of solvent is also very important, and it directly affects the chemical shift. Next, hydrogen bonding. The protons that are involved in hydrogen bonding are typically change the chemical shift values. See, if the hydrogens are involved in the bonding, then the chemical shift value also changes. How? See, the more hydrogen bonding, the more protons is deshielded and chemical shift value is higher. See, the number of hydrogen bonding increases, right? The number of protons is deshielded and chemical shift value is increasing. How? See, if we take example phenol react with deuterium oxide, then I think so it's deuterium oxide itself. You just check it, D2O, and if the hydrogen bonding is happening between the this compound and this compound, and this causes deshielding. This way the chemical shift value increases. Next, complexation. How complexation affects the chemical shift. Metals, lanthanoids, and metals convert to lanthanoids, and then these are very prone to deshielding. Simplification of complex H1 NMR. See here what is happening, right? This compound after complexation, it causes deshielding. Here you can see the NMR spectrum is resoluted. Resoluted means the resolution is after deshielding. This graph is obtained. Okay, in the complexation, what happens? After the complexation, metals converts to lanthanoid. These lanthanoids are again in turn causes deshielding. Okay, you can see the parts per million or chemical shift values. As you can see, it is more complex, and this is not more complex. Here it is not more complex due to deshielding. That's the effect of complexation. Complexation, in simple terms, complexation of metals converts to lanthanoids, which causes deshielding. Okay, next, the last one, van der Waal deshielding. In overcrowded molecule, it is possible that some proton may be occupying steric Hendrik position. Here it is telling that if in a molecule there is a possible that it has steric hindrance position. Okay, electronegative cloud of bulkier groups will tend to repel with the electron cloud surrounding the proton. Here electronegative cloud will repel of bulkier group will tend to repel the electron cloud surrounding the proton. Okay, this electron negative cloud will repel the electron cloud of the protons. Okay, next, such protons will be deshielding and will resonate a slighter higher value of delta than expected in the absence of this effect. Okay, see here what is happening, right? If the protons contain steric hindrance, then it causes deshielding, because this electronegative cloud of bulkier group will repel with the electron cloud surrounding the proton. These two repelling causes deshielding. Okay, these two repelling causes deshielding. it is deshielding, okay, then this causes higher values of delta than the expected in the absence of the effect. If this effect is not occurring, then the chemical shift values may be lower. This effect is occurring, right? So the chemical shift values are higher, slightly higher, okay, considering as van der Waal deshielding. This is considered as van der Waal deshielding. By this we will complete the chemical shift and the factors affecting the chemical shift. In the next class we are going to discuss about the we have completed the chemical shift and factors, okay. Next we will start the spin coupling constant and nuclear magnetic resonance. We will complete this all topic in the next video, and in next video we will complete the NMR spectroscopy and start the mass spectroscopy. Okay guys, thank you guys, please support me, just subscribe or comment, it will make my day, it will surely make my day. And have a nice day, and read well, do well in your semester exam. Take care, bye.